Hello all, welcome to Atom Academy, aspiring leaders in innovation and technology. This video provides you complete information of types of supports and where it is applicable in real scenarios with the examples so that you can correlate the things to apply the boundary conditions, how, why, what constraints we are going to do and how it will be simulating as per the real scenario. Let's go into the video. Introduction. Supports are perhaps one of the most important aspects of the structure. It specifies how the force within a structure are transferred to the ground. So any component, finally it has to transfer to the some of the base, which is ground ultimately. So what is the supports you are going to use to transfer that to ground? The knowledge is required before solving the model as it tells what the boundary conditions are. According to the functionality of the model, according to the selection of the component, we have to consider which support is more relevant. Incorrect basis, that is nothing but supports are called as constraints. In turn, that is nothing but boundary conditions. Incorrect boundary condition causes incorrect results that do not accurately simulate the real life situation. We will be discussing more about this with an examples for each kind of the support so that you will get more clarity about it. The aim to explain different types of supports in this video is to simulate the real scenario examples along with their allowable reactions. That means how the action is happening, how the reaction is happening, and for which part, according to the which physics, we are going to fix the constraints or boundary conditions. Most of us will have a question, is supports depends on materials of a structure. Let us throw some light about it. Various material structures are connected with different ways according to their functionality of the system. How it is, we will see. Structural steel systems have either welded or bolted connections. Precast reinforced concrete systems can be mechanically connected in many ways. So while carrying, while placing, while in the functionality, we'll have different supports and different functionalities. Timber systems are connected by nails, bolts, glue, or by engineered connections. So what we are concluding here, no matter the material, the connection must be designed to have a specific rigidity. So how the connection will have the rigidity according to the physics, that is functionality of the problem. According to that, we have to fix our supports, boundary conditions. So connections in any systems are called as supports or constraints. That is what we are going to see here. Let us discuss first what are the type of supports. Fixed, hinged, roller, rocker, link, simple, frictionless. Still we have so many other support conditions are there, but most popular and mostly we will be using these kinds of only these conditions. That means these are nothing but, always remember, support is nothing but a boundary condition for any model. You can see practically how we can fix the boundary condition in different structures, in different conditions of simulation. That is what we are going to discuss here. About each type of the support, this video gives a good idea and with practical scenarios. To start with, let us focus on fixed support. Fixed support is also called as rigid support. You can see here, if we are fixing means it is capable of resisting all types of loads, that is vertical, horizontal and moments as well. This you can see on the right side of the example what we are talking about. It also provides greater stability to the structure. The best examples we can see beam fixed in a wall or pressure vessel we can fix on the floor or on the ground wherever it is resting on. This is about fixed support with practical. The next one is hinge support. This is nothing but called as pinned support. You can observe here the reactions in vertical and horizontal directions is allowed, but whereas it is free to move in rotations. The best example which we will be using in day-to-day life is door with a hinge. So where we'll have the rotation of the door, but it won't allow any translations. And also the other thing we can notice, suspension bridge or something. Okay. Ultimately, what we can state is it allows the structure member to rotate but not allow translations in any of the direction. That is what the best example is door. I have given only some examples which are relevant. Think in that direction according to the physical sense and the functionality of the component. We always need to fix the boundary condition. Roller support. Roller supports are the best supports you can see in the bridges. So it will allow rolling. That means it will allow translation also axially. Okay, but it won't allow vertical translations. And you can see here, roller support can be in an inclined form, in a vertical form, or in a horizontal form. Here I have mentioned all as horizontal. So sometimes we can, these rollers, if it is working out in different directions, that might be inclined form. Okay. So it will resist only in vertical direction as mentioned before. That means it is unable to resist the lateral loads. If we are applying lateral loads, because of the application of the lateral loads, it may expand or it may form compressive load. Okay, that means only in vertical direction it allows. In bridges, you might you observe this thing whenever you are traveling on the bridges or next to that. It allows to expand or contract based on the temperature changes, where there is a slight variation in the length will happen in the steel properties. That's why on all the bridges, one side they will fix with hinge and other side they will allow the lateral forces. That's why they'll make as roller. Day to day things, according to the application or according to the functionality, how the constraints or supports will change. The next support is rocker support. It is similar to almost like a roller support, but little variation because it will form a curvature on the bottom side which allows only some portion of movement according to the requirement. Majorly you can see this type of conditions in a bigger plants or a machineries, industrial machineries. So it will provide little movement but it won't roll too much. Okay, that is where we will have the rocker support. That means there is a limitation in the horizontal movement, whereas in the roller support there is no limitation. It can expand to whatever free part it can go. And another most important thing is link support. Majorly link supports are used in the trusses, bridges or locomotives, as in the pictures you can see. The link has two hinges, one at each end. You can see how it is. Two hinges, one at each end. This is the process for that. Link allows rotation and translation perpendicular to the direction. Only in that perpendicular direction or normal direction it allows translations and rotations. The best example is you can see in locomotives. That means whenever it is running, the rail tire is running. So in this direction it won't allow, but it can rotate or translate as these things are moving. So when it is in the function or something, you can observe more how it is happening. This is about the link support and along with the practical applications where you can. Simply supported is just a support on which structural members resist on an external structure. This is the best example. You can see a bench on stone, only just a span of wood is lying. So it will resist only vertical movement with the help of gravity. Lateral movement is allowed up to the limited extent. So, but observe one thing, simply supported aren't not widely used in real structures, and also we cannot simulate this in the analysis because it is like a under constraint model. That means only vertically at both the locations we are constraining, means it allows translations and rotations in all other directions. Okay, which will make that model as under constrained model. Okay, the next one is frictionless support. As I have mentioned earlier also, according to the model consideration, the boundary conditions keep changing. So if you are considering the complete pressure vessel, we observed that the bottom legs are fixed to the ground. When we are selecting only half of the portion, that is as a symmetric portion, you can see on the cut region we are applying frictionless support. That means it is nothing but normally we are constraining. It is a type of the support used to constrain degrees of freedom in normal direction. So it is always used to prevent one or more flat surfaces or curved surfaces from moving in that direction. Since we have cut this section, the reaction forces will will affect. That is why we will be applying the frictionless support at the symmetric faces, okay, along that direction. So where we can use, as again I am saying, according to the consideration of the model, this is nothing but mirror symmetry condition or reflective symmetry condition also we can, or so many different kinds of symmetry regions. Wherever it is there, we can go for frictionless support. Discussed about each and every support along with the real scenarios so that you can observe the functionality, and according to the functionality which support suits a lot. To summarize all these things, some of the information has given here. In the hinge, as we are allowing rotations, only in reaction forces will happen. In the roller, only Fy direction. Rocker means it is also Fy with some limited rotation. Link, you can see normal to that direction. That means perpendicular to that direction we are having the force. Whereas fixed support, we'll have all three directions, forces and also moment. So considering this as a 2D effect. If we have 3D, we have to consider about FZ condition also. To avoid confusions, we are giving in terms of 2D for the better idea. So about the characteristics of each type of support also we have mentioned. You can see prevents movement in vertical and horizontal direction but allows rotation in hinge. Whereas in roller and rocker, it prevents in the vertical direction but allows rotation and translations. Whereas links are the best example for bridges or welded regions. Okay, does not allow translations or rotations in any of the direction. This is about fixed condition. So hope it gave a good insights of when to use which type of supports, how to replicate the real scenarios according to the physics of the model in the simulation process. Keep watching our videos for more technical knowledge. Thank you. Have a nice day. You can reach us to this number or email address for more details or career assistance. Have a great day.